Hello everyone. In this video session, we are going to learn about 555 timer. Let me learn the basics of 555 timer. It is an 8-pin IC. The pins are ground, trigger, output, reset, control voltage, threshold, discharge and VCC supply. This 555 timer, it is a waveform generating device. It is used to generate non-sinusoidal waveforms like square, ramp and pulse. It is also used to produce time delay. Basically, it is used in the application for waveform generation, triggering alarms, water level control, etc. It works in three modes: astable, monostable and bistable mode. We have learnt about astable mode, monostable mode and bistable mode earlier. The same definition goes here also. Now let me see the block diagram of 555 timer. So when you look into the block diagram of 555 timer, there are three resistances of 5K connected in series. So this is going to form a voltage division. Since all the three resistance are equal and it is most probably equal to 5, hence the name, it is believed that it has obtained the name of 555. There are two comparators, lower comparator and upper comparator, and one SR flip-flop. Let me see how this 555 timer is going to work. So the lower comparator, the positive is connected to 1/3 of VCC and the negative is connected to trigger. Whenever the positive terminal voltage is higher, that is it is equal to greater than 1/3 VCC, or the trigger input is less than 1/3 VCC, then this lower comparator will produce an output of 1. So that 1 is fed to S of SR flip-flop, the set pin of SR flip-flop. So what happens is your output is set to 1. You can see here your output is set to 1. When output is set to 1, the Q dash will be equal to 0. So that Q dash is fed to an inverter. Here it is 0. It is fed to an inverter. When 0 is fed to an inverter, this output will become 1. Now let me see what happens in your upper comparator. The upper comparator will produce an output of 1 when the threshold is greater than 2/3 VCC. The negative pin is connected to 2/3 VCC. Negative pin and the control voltage both put together are connected to 2/3 VCC, and threshold is 2/3 VCC, that is given to the negative pin. Threshold is given to the positive pin. When the threshold voltage is greater than 2/3 VCC, positive voltage will be higher. When positive voltage is higher, this upper comparator will produce an output of 1. So reset is given a value of 1. When reset is 1, then your output will be reset to 0. Your output will be reset, your Q of t will become 0. When Q of t becomes 0, Q dash will become 1. So Q dash is 1. When Q dash is 1, it is fed to the inverter. So that inverter will make my output to 0. Again you can see this Q dash is 1, that is fed to this transistor Q1. So transistor will be, now it will be in the conducting state. When your transistor Q1 is in the conducting state, it will help to discharge the current to ground. So this is how your 555 timer is working. Now, as said earlier, there are three modes of operation. One is astable multivibrator operation using 555 timer, monostable and bistable. Let me see what is astable multivibrator, how astable multivibrator operation is going to happen in 555 timer. Astable multivibrator, we have learnt earlier, neither of the states is stable here. It will be continuously toggling between positive voltage and negative voltage, between higher value and lower value. That is called as an astable multivibrator. The block diagram of your astable multivibrator is this. You can just compare with the previous block diagram. When you compare it, you can see that there are two resistances RA, RB, and a capacitor is connected in additional in the circuit. Let me see how the circuit is going to work. Initially, I assume that VC, that is the capacitor voltage, is less than 1 by 3 of VCC. Capacitor voltage is connected to the negative terminal of lower comparator. It is the trigger input. It is connected to the negative terminal of lower comparator. And assuming that this capacitor voltage is less than 1 by 3 VCC, what will happen? This lower comparator will produce an output of 1. When that 1 is fed to the set pin, your output will be set to 1 and your output complement will be set to 0. So when this is set to 0, you can see that your output complement is 0, so that is fed to the inverting power amplifier. Here your output will become 1. Here it is 0, so that 0 is fed here. Your Q1 cannot conduct now. So Q1 will be in the off state. When Q1 is in the off state, what will happen here is that the capacitor will try to charge from RA and through RA and RB. It cannot discharge. So capacitor this is in off state. So your capacitor cannot discharge. So your capacitor will try to charge with help through RA and RB. Capacitor charge will be continuously increasing. At one state, what will happen is that it is going to increase from 1 by 3 VCC. It is continuously increasing. At one state, it will become greater than 2 by 3 VCC. You can see this capacitor is also connected to the upper comparator. So when the capacitor voltage becomes greater than 2 by 3 VCC, the upper comparator will produce an output of 1. So that is fed to reset pin of flip-flop. Reset pin of flip-flop is equal to 1, which means that your output will be reset. Your Q bar will become 1. When Q bar becomes 1, that 1 is fed to this transistor. Transistor will turn to on state. When transistor becomes on, now the discharge will be enabled. Capacitor will try to discharge. It will discharge to ground. Capacitor will be discharging to ground at one condition. So what will happen is that this capacitor voltage becomes less than this 1 by 3 VCC. Then this lower comparator will become active. So this process will be continuously happening because of the charging and discharging of your capacitor. There is a shift between your output between positive and negative. So you can see that your output will be toggling between positive and negative continuously because of this astable operation. So the output graph, you can see capacitor is charging from 1 by 3 VCC to 2 by 3 VCC. So in that case your output is 1. Then when the capacitor discharges, your output will become 0. When again capacitor charges, your output is 1, and during discharge output becomes 0. So the charging time period is called as TH and discharging time period is called as TL. Charging is going to happen between the two resistance, that is RA and RB. Here it is denoted as R1 and R2. 0.693 into R1 plus R2 into C1. And discharging is going to happen because of only one resistance, through one resistance, that is RB. The total time period is a summation of your higher period and lower period, that is TH plus TL. Summing up these two values, you get it to be 0.693 into R1 plus 2R2 into C1. The frequency of oscillation is inverse of this time period. So getting the inverse, we get the frequency of oscillation. So this is the operation of astable multivibrator. Now let me see monostable multivibrator. We have learnt about monostable multivibrator earlier with operational amplifier. Here one state will be stable, the other state is quasi-stable. Even in 555 timer, we can get this monostable operation. So here, initially, let me see how the circuit is going to work. The circuit diagram of monostable operation is given here. So this is taken from howtomechatronics.com. Let me see how the circuit is going to work. Initially, the triggers to the trigger pin, a switch is connected and this switch is in open state. So when the switch is in open state, the VCC, the supply voltage, will flow through the resistance R2 to the trigger pin. Similarly, the supply voltage flows through the resistance, the three resistances it creates a potential division of 1 by 3 VCC and 2 by 3 VCC across the lower comparator and upper comparator. And again, the discharge happens through resistance R1 through your transistor Q1. So here, when the trigger pin is 0, the trigger pin is not initiated, the voltage VCC will appear through the trigger pin to the lower comparator, and you can see here, since the lower comparator, this voltage will be greater than 1 by 3 VCC, the output here is 0. Similarly, in the upper comparator, your 2 by 3 VCC voltage will be higher, so your output is here again is also 0. Both your set pin and reset pin are at 0 level, hence the previous state will be maintained, which means that the previous state we assume that Q bar is equal to 1. So the discharge is initiated, the transistor Q1 will be in on state and discharge will be happening through the resistor R1 to the ground. So capacitor will not be charged in this condition. Now I need to change the state. To change the state, what I'm going to do here is that I'm going to press the switch S1. S1 is pressed. When S1 is pressed, trigger input is given. I'm going to give the trigger input. When trigger input is given, what will happen here is that trigger input is given. So your lower comparator, what will happen? All the current from the VCC will flow to ground. It will not go to the lower comparator. So now in lower comparator, 1 by 3 VCC will be higher. When 1 by 3 VCC is higher, this output will be set to 1. So set pin of your flip-flop will be higher. So when set pin is higher, Q will become 1, Q dash will become 0. When Q dash becomes 0, this output 0 is fed to the output. This is an inverter, so your output will become 1. So Q dash is 0. When Q dash is 0, you can see that this discharge transistor will also be 0. So discharge will be off. This transistor is no more in conduction mode, so discharge will be off. When the discharge is off, your capacitor will try to charge because no current flows here. So current flows through the capacitor and capacitor will try to charge to the resistance R1. So capacitor will be continuously charging. At one condition, this capacitor will become greater than 2 by 3 VCC. When the capacitor voltage becomes greater than 2 by 3 VCC, this upper comparator will produce an output of 1. So when this upper comparator produces an output of 1, reset pin will be high. When reset is high, Q will become 0, Q bar will become 1. When Q bar becomes 1, transistor will be in the on state, transistor on, discharge will try to happen. So when discharge happens, capacitor will discharge. So capacitor will start to discharge and it will be continuously discharging. And what will happen? One condition, your capacitor reaches its value, your output will be toggled. So now you can see, then again if I need to go to the initial state, I have to give the trigger pin. Then again the condition should repeat. So this is the operation of monostable multivibrator. So we have learnt about what is 555 timer, what is astable multivibrator operation, and what is monostable multivibrator operation. In bistable multivibrator operation, instead of a single switch, you will be having two switches. So on turning on and off the two switches, you can change from one state to another. That operation is very simple and it will be similar to that of monostable. The only difference is that you will be having two switches. By turning on and off of the switch, you can change from one state to the other state. So this is all about the working of 555 timer. Thank you.